Let me introduce myself. My name is Jon Neefs, Business Support Manager at Iris Industry Solutions located in Belgium. Iris is one of the largest industrial coating application companies in the Benelux. This technical film will guide you through each step of the zinc thermal spraying process. Zinc thermal spraying is the process by which a zinc-based layer is applied to a steel surface by means of spraying. Thermally sprayed zinc or zinc aluminium, also known as metallisering, provide an ideal long-term protection of steel against corrosion, especially in very aggressive, corrosive environments such as marine locations. A continuous exposure to seawater, which means exposure to water and chlorides, combined with UV radiation from sunlight, create extremely harsh environmental conditions. Three mainstream corrosion protection systems utilize thermal sprayed zinc. The first one is called thermal sprayed zinc coating, or TSZ. The second is called thermal spray zinc alloy coating, or TSZA, which uses zinc aluminium specifically for marine conditions. The third is called duplex systems, where an additional protective paint layer is applied on top of the thermal sprayed zinc or zinc alloy coating. The most suitable system depends on the requirements of the end user. A coating consultant can provide expert advice, but let's take a quick look at the systems in more detail.
Pure thermal sprayed zinc or zinc aluminum coatings can be used when there is no requirement for a specific color or if you want to keep maintenance to a minimum. Duplex systems are often used for aesthetic purposes, but the paint layer on top of the thermal sprayed coating provides additional protection as well. The expected lifetime of a zinc coating depends on its thickness. A thicker coating will provide a longer lifetime to a steel structure. All three systems can protect against corrosion for up to a century with minimal maintenance, reducing total life cycle costs and contributing to the sustainable and durable protection of steel structures. When a steel structure with a zinc coating is recycled at the end of its lifetime, the zinc can be recovered from the recycling process. New zinc can then be produced from the recovered waste stream. To achieve the expected lifetimes with minimum coating maintenance, all three systems need to be applied according to international standards. The work needs to be undertaken by a well-trained coating professional under the supervision of engineers. ISO standard 12690 describes the tasks and responsibilities of the supervising personnel for thermal spraying. The supervisor makes the inspections, creates the test plan, carries out the quality assurance, and prepares the corresponding documentation. In many cases, this is a FROSIO or NACE inspector with additional training, according to ISO 12690. Engineers, technicians, and foremen can also be trained for this. ISO 14918 regulates the trainings of applicators. The Inspection and Test Plan, or ITP for short, is a summary of the standards that govern the actual application process in this example. Standard ISO 2063 is the overall reference standard for thermal spraying of zinc and zinc aluminum. We will explain the most important standards in more detail during the following step-by-step application process. However, the full set of required standards needs to be applied in praxis. Thermal spraying zinc or zinc alloys can be performed in two ways: arc spraying and wire flame spraying. Arc spraying has a higher application rate than wire flame spraying and is therefore often used for spraying large surfaces of steel bridges. However, this method requires electricity and the equipment is heavier than that used in wire flame spraying. Flame spraying equipment is often preferred at the construction site of a bridge because it's more mobile. The coating quality of both systems is comparable, and both systems can be used for the same construction. As an example, let's look at a bridge crossing the Albert Canal in Belgium. Here, a duplex system is applied. The thermal sprayed zinc aluminum alloy consists of 85% zinc and 15% aluminum and is finished with an organic top coat. Employees from Iris will now show how arc spraying is used for this bridge in the workshop of Belgian manufacturer Victor Bike, a leading international steel construction company specialized in high-rise construction and bridges. The company's coating applicators will then demonstrate how wire flame spraying is performed at the construction site of the bridge. Before we start with arc spraying, the steel has to undergo grit blasting. The first thing to do when preparing for grit blasting is approve the ITP before instructing the applicators accordingly. To ensure a proper application, the environmental conditions listed in the ITP are thoroughly checked, with special attention given to temperature and humidity. Both need to be controlled to avoid reaching dew point and condensation appearing on the steel surface. The grit blasting process is performed in a controlled atmospheric environment, in closed cabins, or in the workshop. At the next step, the surface of the steel is degreased. For safety reasons, the grit blaster must put on a mask and helmet with an external fresh air supply. The mask and helmet are kept at a slight overpressure to keep out dust. The grit blasting can now proceed to clean, prepare, and profile the steel surface. Thorough grit blasting is critical to ensure effective adhesion and long-lasting corrosion protection of the thermal spray coating. The grit consists of sharp-edged blasting grains as opposed to round grains. This creates a sharper profile and helps the zinc to stick better to the steel. A separate test plate is also grit blasted, so it can be thermal sprayed for destructive adhesion testing. After grit blasting, dust is removed from the surface and the surface is inspected. Is it clean and rough enough? Does it meet the required standards? A visual inspection and a tape test ensure the surface is sufficiently clean. The grit used for blasting is collected and sieved for reuse. To provide optimal corrosion resistance, a professional and thorough thermal spraying of the zinc or zinc aluminum coating is critical. A controlled atmospheric environment is also essential. The following steps will show you how the zinc or zinc alloy is thermal sprayed onto the seal substrate using an arc system. The protective suit used by the thermal spray operative for arc spraying is the same one used for grit blasting, although the mask is darker to protect the eyes against the arc. Arc spraying equipment consists of the spray gun, power supply, and a pressure unit for dry air. Two electrically charged zinc or zinc aluminum wires are brought together at a controlled rate to form and sustain a stable electric arc. The heat generated by the electric arc melts the wire tips. The gun's atomizing airstream propels the molten material toward the substrate to form a metallic coating. The feedstock material can be either zinc or zinc aluminum wire, supplied in barrels, coils, and loose rings. Here we use barrels with zinc aluminum wire. It isn't necessary to pre-coat the edges when thermal spraying, but small angles or crevices should be avoided around the corners when designing steel components. The operator should be able to easily reach every area with his blasting or thermal spraying gun. For optimal results, it is important to keep a distance of around 150 millimeters between the gun and the surface. To build the necessary coating thickness, the operator applies several layers of zinc by making multiple passes with the application gun. During the application, the operator measures the thickness of each layer. Depending on the specification requirements, there are several application ranges with varying minimum and maximum thickness. If necessary, the steps have to be repeated until the required final thickness is achieved. The test plate, which was grit blasted earlier, is now metallized. An adhesion test, usually performed with a pull-off test, can take place either just after metallizing or after applying the top coat, depending on your agreement with the customer. In the former case, the sprayed coating is measured to ensure sufficient adhesion for further coatings. Different types of tests can be agreed with the contractor or customer. During thermal spraying, the steel will only become lukewarm. This is important as it means the material quality and mechanical properties of the steel are not affected in any way. The absence of any need for curing time enables the steel to be processed straight away. Thermal spraying produces a fine and coarse overspray, which is collected separately. The fine overspray dust is removed from the air by the workplace exhaust system. It can be collected in the filters of the extraction system and stored in barrels, recycled into new zinc products, and resold. The coarse particles of the overspray fall to the ground, where they are swept or collected with a vacuum cleaner to be recycled. The overspray, which has accumulated on the surface of the coating, is removed with compressed air or a vacuum. The surface is then inspected in preparation for the next step, applying the sealer. Currently, thermal spraying of bridges is performed manually. In the future, however, automatic lines may improve the quality, consistency, and efficiency of the process even further, and facilitate local capturing of the overspray. The sealer is an initial organic coating with a very high fluidity, low surface tension, and low viscosity. It closes the pores of the zinc or zinc aluminum layer to create an ideal base for a further coating of paint. A correctly applied sealer avoids pinholes in the top coat, which are difficult to repair. A sealer is part of the thermal sprayed metallic coating as standard and not to be considered as an additional organic coating. After sealing, paint is applied and the dry film thickness of the paint coating is measured. To finish, a test measures the adhesion of the entire duplex system to the steel. During the thermal spray process at the steel manufacturer, welded areas of the steel parts are deliberately left blank. This is called masking. The final welding is undertaken during assembly at the construction site. All welded areas should be finished with thermal sprayed coatings and paint on site. When the pre-assembled steel parts are ready, they are transported to the construction site. Once the bridge has been erected, a lift and scaffold move the thermal spray equipment to the working area, high up on the construction. The scaffold requires a 360-degree enclosure or tarpaulin to control the atmospheric conditions and prevent condensation appearing on the surface. It also contains the waste generated by the grit blasting and the overspray, which is extracted passing through a filter unit. The next steps are the same as we have seen at the workshop. First, the grit blasting is done. Dust and debris are then cleared. Finally, the surface is dusted and inspected for cleanliness and smoothness. Now the thermal spraying procedure begins. Once the bridge is erected, small repairs or reworks are usually performed by wire flame spraying, which is easier to manage at this stage. Wire flame spraying does not require electrical power supply, and the equipment is lighter compared to arc spraying. The protective suit for wire flame spraying is the same as the one used for grit blasting, which means that the mask does not need to be darkened as it does for arc spraying. The equipment for flame spraying consists of the spray gun and machinery, plus a compressed air unit. The wire feed rate and flame settings must be balanced to continuously melt the wire tip and create a fine particulate spray. The annular compressed airflow atomizes and accelerates the particles toward the substrate. Once again, the raw material is zinc or zinc aluminum wire. In this case, zinc aluminum wire is used. During the thermal spray process, it is important to retain a distance of around 180 millimeters between the gun and the surface for optimal results. The operator applies several layers of zinc aluminum to achieve the required coating thickness and measures the total thickness of the layers. A separate test plate is coated, on which a pull-off test must be performed. After spraying, the operator cleans the thermal sprayed surface from overspray using compressed air or vacuum, and then applies the sealer. The zinc overspray is also captured on the construction site. Coarser particles fall to the ground and are either swept or vacuumed, while the finer overspray is extracted and separated via the filter installation. It can then be recycled. Once the sealing is complete, the thermal sprayed surface is immediately finished with the top coat. Customers can often ask about the differences between thermal spraying and hot dip galvanizing. Very often, structures can be hot dip galvanized, although thermal spraying is preferred in some situations. Hot dip galvanizing can only be applied to newly produced steel parts at the plant of the galvanizer. That means that the steel first has to be transported from the steel manufacturer to the galvanizing plant, an additional step which costs time. Thermal spraying can be done directly at the steel manufacturer's site for newly produced steel. Additionally, it can be used in the field on existing bridges. Thermal sprayed zinc also adds value where large steel parts cannot be galvanized due to the limited size of galvanizing kettles. Thermal spraying is a cold process during which the steel only becomes lukewarm. This makes it the best choice for any steel section sensitive to heat-related distortion. Thermally sprayed coatings can be produced with alloys adapted to the corrosion conditions. Thermal spraying also offers a lot more flexibility in coating thicknesses.
Today, bridges are specified to last for more than 100 years. Thermal sprayed zinc coatings are versatile, durable, and require minimum maintenance. With their low life cycle cost, it provides a sustainable solution for protecting our critical infrastructure for a very long time.